Hello, I'm Rada, and I'm going to explain something really important. So logic has been changed in the past few builds, in the past two builds actually. So you know how I was talking about the functions a-tan2 and dst? Well, those have changed their names. If I go into operation and I go in, not only do we have a new shiny UI which can display, hopefully display comparisons. Alright, it can't. So not only do we have renames like angle and len, which are a-tan2 and dst respectively, we also have strictly equal. Now, strictly equal basically checks if 0 is equal to null. So basically you can tell that apart now. Normally this would be true because this is basically the same value, but if you do 3 equals, it's not the same type, so it's going to output false. There's also something else that was added. I'm not particularly sure what that was. Oh yeah, right. So what I didn't discuss in my video was certain variables, like for example map h and map w. Let me actually not do anything here. Map h space map w. What is it gonna do is it's going to print the map size to a message block, which is 256 by 256 as expected. But there's also new variables such as time. Actually, no. This one's old. This one existed. Tick. Sorry. And I think there was another variable. I really have to look into the source for this, but this is what tick the game is currently executing. It's printed out as the first number. It changed a lot. Not really good for bitrate. Oh, and another thing, you can now make units copy things. So you could bind a mega. You could. This is interesting. So there's a new idle subcommand. I think that's just gonna make them uncontrol themselves, of course. And of course, the build command was changed. You can now config. This means you can build self-replicating processors now, which is really cool and also really terrifying at the same time. To complement this, a new game rule was added called, I think, logic unit build. Yes, that was the game rule, and by default it's set to true on everything except for multiplayer. Maybe you should probably disable it if you're in multiplayer because well, honestly, you're not really gonna need it. And of course we need to talk about certain things that I didn't discuss in my tutorials, but I feel like I'm obliged to describe anyways. So unit radar and radar are the same instruction. They are literally the same instruction, except this would be written better as radaring from @unit, and this should turn into a unit radar. Of course, that doesn't happen because parsing everything not real good. I think they also had some I think Nuke also added some sensors as well, so let me take a look. Yes, I see some new sensors here. So timescale, it tells you how overdrive something is. Size is, well, it's just size. Dead shows you whether unit is dead or not. You can just check the health equals 0 though. You can check if a unit is shooting. Wait, no, that existed. You can check whether a unit is boosting or whether it's commanded or controlled. Actually, I don't know what the difference between these two is. I'm pretty sure that this is referring to logic control, and this is referring to pressing G on your keyboard. And then, of course, there's config, which just exists. By the way, configure does literally nothing, still. Another thing is, you can print things. So if I try to print at tetrative reconstructor and then print it to a message block, you're going to get tetrative reconstructor. You're not going to get object anymore like you used to. And of course, now to take a look at the actual logic things. So compiled arrays were really hard for people to understand. I really didn't think it would be this hard to transfer over, but I can explain it in C code at least. So let's say you want a implementation of the whole function thing. Maybe you want compiled arrays in normal execution. So in C, what you would normally do, actually no, I'm not going to include anything, screw you. So basically in C, what you would have is you would declare an array with, I really don't understand double. So you would normally just initialize an array like this. So you made an array, cool. The next thing is you need to actually be able to write into it. In C, how you would do that is array 0 equals 1337.0, and you can continue that for the other variables. But in mlog, it's really weird. So let's say this is the beginning. Let's say this is the write function. So what we're going to do is we're going to actually take x and we're going to multiply it by 2. Op mul basically what this does is it's going to multiply x by 2, which is going to multiply the pointer. You can actually increase this by 3 to 3 and even 4, depending on how many things you're storing in your array. Of course, this means you can store structs in your whole thing. And the next thing you do is you add the array index to your counter. So add counter, which is basically just counter plus 1 array index. Amazing. So what you have to do now is you need to actually make the array. So if your array index is 0, this means you start from this line. So you just set. Actually, no, you're writing. So you can use the same nomenclature. This is still a variable. Set at counter callback Then you can just do it again, array 1, array 2, array 3, and so on and so forth. It just kind of works. You can extend it to reading as well. So you just, instead of using y, you just use array 0, and then you set some output variable. Maybe use the same y, but I prefer to use array output. And of course, if that wasn't complex enough, people also wanted to store units as well, and people have made unit array schematics too. So unit schematics, wait for it, they just store flags of units and they just use stuff. That's boring. You can just store it all inside of the processor using compiled arrays, because you can write units to variables and oh shit. And the next thing and of course the last thing I'm going to talk about, because this video is getting really boring, really long, like 10 minutes without anything interesting. Come on, router, what are you doing? You can input raw bytes now. So what you want to do is you want to place a processor. You don't really need a fast processor. You link, actually no, that was a really bad processor. So you place a processor, you link it like this. So because there's 16 sorters, you're gonna get 4 bits of input that way. And because every sorter can be configured to 16 different items, that's 4 more bits. So this is basically just 256 buttons. Jesus Christ. This is more than you'll ever need, but it's pretty good if you want to have multi-choice things and you don't want to really interfere with anything else. Also, side note, I'm going to be making a RISC-V32G processor. Of course, not including floats, because floats are going to be really slow to implement as opposed to doubles. And stay tuned. I'll see you in the next episode.